This is a continuation of the System Components course module. In this course module, we will be first starting with the motherboard, of how various devices are interfaced by the motherboard, how they are interconnected to each other, what are the various devices that are present on the motherboard, whether we can make any additions or remove any components, any unrequired components from the motherboard as per our requirements. And then we will be studying about the BIOS, the basic input-output system. As soon as we press the power button for our computer, the control is given to the BIOS. The BIOS starts with the post, that is the power on self-test, and then goes to the master boot record, which tells us where in the hard disk is the boot record present. From there, the control is given to the operating system. Now, with the help of a YouTube video, we would be starting learning about the motherboard.
The motherboard can be compared to the nervous system. Nearly every component relies on the motherboard and is connected to it in some way. It is essentially a circuit board with paths or traces that transmit power and relay commands to the other components to tell them what action is needed. For each action, an electronic impulse is sent to the motherboard. The board determines what the impulse is, what is needed, and which component must be implemented to complete the function. For instance, when you hit the A on the keyboard, an impulse is sent to the motherboard. The motherboard sends the impulse to the video card, or onboard video system. The video card determines that the letter A is needed and sends that information back through the motherboard. The board then determines where the information gets from there, in case the monitor where the A seems to appear instantly even though many processes have occurred in order to get there. Another example is when you click an icon to an open program. Again, an impulse is sent to the motherboard. The motherboard then signals the hard drive to load the information into RAM. The motherboard then sends a command to the video card so it can calculate what needs to be drawn, like text, colors, images. And the video card sends that information back off the motherboard, which sends it to the monitor. All of these things take place so quickly that the information goes from a click of the mouse to an image on your monitor in mere nanoseconds. As you can see, the motherboard is one of the most important parts of your system. Make sure it is compatible with your other components and make sure it is a good stable board.
Motherboard. As the name suggests, the motherboard is the main circuit board of a computer which helps to link everything together and run the computer. A motherboard is a printed circuit board. That is, all the interconnections are on the board itself. It is found in all modern computers and holds many of the crucial components of the system, such as the CPU and memory. Motherboard specifically refers to a PCB with expansion capability. The board is the mother of all components attached to it, which may include sound cards, video cards, network cards, extra hard drives, or other forms of permanent storage. Let us now have a look at the components of the motherboard one by one. The CPU, or Central Processing Unit, is the hardware within a computer system which carries out the instructions of a computer program by performing the basic arithmetic, logical, and input-output operations of the system. When a computer is in use, electrical activity within the CPU generates considerable heat which needs to be dissipated. A heatsink is secured to the top of the CPU, providing an efficient path for heat to escape, first into the heatsink, then from the heatsink into the environment. Functions of a CPU. The functions of a CPU can broadly be divided into 4 parts which are performed sequentially. Fetch refers to the process of taking the instruction from the memory. The instructions are then decoded and converted into binary instructions which are understandable to the CPU. This instruction decoded is then executed by the CPU and necessary actions are performed. The output data is then written back to the memory. RAM refers to chips that temporarily store dynamic data while we are working with our computer to enhance the computer performance. It is used to hold programs while they are being executed and data while it is being processed. Random access memory is volatile memory, meaning it loses its contents once power is turned off.
BIOS stands for Basic Input and Output System. It contains a set of instructions that run from the time the computer starts to the time the operating system takes over. The primary function of the BIOS is to identify and initialize component hardware, that is, the hard drive, the video display card, CD/DVD drive, keyboard, mouse, etc. When we turn on a computer, the BIOS does several things. The usual sequences: check the CMOS setup for custom settings, load the interrupt handlers and the device drivers, perform the power on self-test, which basically tests for the system hardware, and initiate the bootstrap sequence. BIOS interaction. On startup, the BIOS provides the routines necessary to test and configure the hardware and use the peripheral devices included on the motherboard. To enter the BIOS screen, press any of the following keys: F1, F2, delete, escape, F10. As soon as you power on your computer, you will see this screen. Here you can change the system time and the system date. You also get information about your hardware, the BIOS version, the product name, the CPU type, the size of various memory storage locations, L1, L2, L3 cache, your hard drive, and the total memory. You can also safeguard your computer by putting a password. You can change the boot device priority by using the arrow keys, and you can exit having several options.
Motherboards also include a small separate block of memory made from CMOS RAM chips, which is kept alive by a battery even when the computer's power is switched off. This prevents reconfiguration of the PC when it is powered on. The CMOS RAM is used to store basic information about the PC's configuration. For example, CPU, RAM size, floppy disk and hard disk drive types, serial and parallel port information, plug and play information, and power saving settings. Time and date are also stored in the CMOS memory. This is updated by a real-time clock. Chipset refers to a group of small circuits that coordinate the flow of data to and from key components of a PC. This includes the CPU itself, the main memory, the secondary cache, and any other devices stored on the buses. The chipset also controls the data flow to and from hard disks and other devices connected to IDE channels. The two main chipsets on a typical motherboard are the North Bridge and the South Bridge. The North Bridge is also called the memory controller, as it is in charge of controlling transfers between the processor and the RAM, which is why it is physically located near the processor. The South Bridge is also called the input-output controller or expansion controller, as it handles communications between peripheral devices. This diagram depicts the connections of the North Bridge and the South Bridge on a typical motherboard.